Right. Okay, so quick look at the growth of APIs. You might have heard of Programmable Web, which has been tracking the growth of public APIs since 2005. Right? So within this year, mid this year, June, it reached the 22,000 mark. So these are the public APIs which are consumed by public, you consumed by the public, right? These are not the private APIs you're talking about. So imagine the millions of other non-public APIs which are hosted or exposed through microservices, web apps, mobile apps, IoT devices, and whatnot, right? So there's a rapid growth that you can see. And according to the Programmable Web, what they have noticed is APIs are now a core part of all the businesses, right? So be it REST, gRPC, or GraphQL, these are core part. So it is important that we take steps to secure them, to access them securely. So in this presentation, this is about API best practices, but maybe more suitable would be RESTful API best practices. So I'm not going to talk about gRPC or GraphQL here, but the same principles might apply since all are running on HTTP, right? Okay, so in any secure design, be it an API, web app, or anything, there are 6 key attributes that you have to cover in order to call it an secured API. So these concepts you might be familiar with. So I just want to refresh. And a lot of concepts that we are going to cover in this session might be also familiar to you. But let's take a look. Maybe there's something that you can learn new. So these 6 pillars, we can call it. One is the authentication. That is only the legitimate users can access the system, no one else, right? So there are authentication protocols like SAML2SSO, OpenID Connect that can be used in your applications. So most common is the OpenID Connect. So we'll get into that later. Then authorization is those legitimate users, authenticated users can do only what they are allowed to do, nothing more than that, right? So you might be using rule-based engines, maybe. You might be using different policies, maybe, to authorize. You might be using role-based access control to authorize, right? There are different mechanisms that you can use to ensure this. Then confidentiality means the sensitive data can be viewed only by the authorized parties, no one else. The integrity, so within the in a transaction or when a message is getting passed, if something got changed, then the system should be able to immediately identify that change and reject that request. That is integrity. So confidentiality and integrity. So confidential, especially, you have to check that during the transit, when transmitting, as well as at rest, right? So during the transmit, the most common is to use TLS, transport level security, if it is HTTP, right? So at rest, you can use different encryption mechanisms to protect that. So for integrity also, TLS supports that, and also signatures. So we'll get into that a little bit later when we are talking about JSON web tokens. Then non-repudiation. That means an entity cannot deny its action. So after I send a request to an API, later I can't say I didn't do that. So how do you do that? Login, right? And again, signing. So these are the key aspects, how you make sure that non-repudiation is there. And availability is the system should be available at all given time to all its legitimate users. So you have to do monitoring and all those infrastructure level things. Scaling, all of them come under this. So in this session, I'm mostly going to focus on authentication and authorization. So those two itself are quite huge. So we don't have enough time to cover everything, right? Okay. So I am hoping to touch these areas you might be quite familiar with: HTTP basic authentication, API keys, OAuth 2.0, OpenID Connect, JWT-based authentication, TLS Mutual Authentication, SACML, and OPA, right? That is the Open Policy Agent. The last two are for fine-grained access control. Okay. So this is pretty simple, right? Basic authentication, I believe everybody knows about it, right? But I must mention about the problems of it and why it is not recommended. So to whoever who are not familiar with basic Oauth, it simply is a standard from the Internet Engineering Task Force. You simply put a username and password, you encode it with base64, and then send in an HTTP header called authorization. Right? That's basic Oauth. So there's no, it's in plain text, right? Even though basic encoded, anyone can decode that. Right? So you must make sure you are using TLS or any transport level security mechanism to make sure those credentials are protected. So this is quite easy to implement. Still, there are a lot of APIs that are supporting basic Oauth. So what are the problems? So you are dealing with passwords here, right? Sensitive stuff. There's an increased probability of leaking a password when you are using basic Oauth. For example, for each request, you must send this header. Why? HTTP is stateless, right? And REST APIs, they don't maintain sessions based on cookies or whatever. Right? So you must send. So there's more probability of leaking or exposing the password. And it needs to be stored in all the clients that are doing this basic Oauth call to the API. So it needs to be protected there. Again, it increases this threat surface, right? A lot of places to protect. And also within the communication, it can get logged in proxies and other intermediary components, right? So usually only the GET requests are logged, but you can configure it to log even headers, right? We don't know how the intermediary ones are configured. And performance hit in some scenarios, like for example, in microservices architectures, right? Dealing with username password might be a performance hit because you have to go to the user store and get it validated and come back, right? So that also a drawback of this. But still, can't you use it at all? I mean, should you give up everything and start using Oauth 2.0, something like that? There can be some scenarios. For example, if all the communication happens with a trusted system where maintained by your DevOps or admins, right? The communication between those systems maybe can use basic Oauth. Because your admin knows where all the credentials are stored and how they are protected, right? And these are your users. The user store is also in that system, so it's fine, right? Also, that plus, if the latency of the validation is not a problem, yeah, that should be fine to use. But still, there are other methods like Oauth. So if you can move forward to Oauth, then do it. Don't stay there. Right? Then if you are going to use it, what are the security precautions that you should use? TLS must, right? It goes in plain text. So you have to use mechanisms to protect the passwords. So at config files, you have to use encryption, use dedicated secret managers like vaults and hardware security managers. Hash the password in the user store rather than encrypting it. Also, this is important, use separate service accounts rather than using user accounts, for example, of your admins. So I have seen that happening, right? So when something happens to the admin credential, then the whole system goes down, right? Because you have to go and change every place. So use a separate service account and make it strong and unique. So if you can remember the password of your service account, that's not strong enough. Simple as that. Right. So moving to the next one, that's API keys. Right? So you might have used Google Maps and a lot of other APIs where you send a key and simply it's done, right? But is it secure enough? So API key is just a unique random number, right? Generated by some system. There's no standard specification protocol governing the secureness of that API key. So the system who's generating decides what the strength of that key is, right? So it's quite easy to implement. So we are using it. But is that all right? So what are the problems of it? API keys were never meant to be a proper authentication or an authorization mechanism. First of all, it doesn't identify an end user in most of the cases. It identifies an application, right? And you can't give granular level authorization to a key. Usually you get all or nothing access. You get a key, you can access all the resources of that API, right? And again, those are very long living. There's more probability of leaking them. And keys can get passed around, right? So one developer say, hey, Machan, what's the key to this service? Here you go, right? And you call. So the keys are all over the places, the same key gets replicated. And sometimes people push these to source repos. It has happened. There are tools to monitor source repos to see whether there are any keys getting leaked, right? So it happens. And usually those can't be programmatically revoked. The developer has to go to a developer console and change the key, right? The app can't do that by itself. Then again, since there's no standard, there's no enforcement of TLS unless the server decides to enforce TLS. If it allows HTTP as well rather than HTTPS, then these go in plain text, right? Okay. But again, can we still use it in some scenarios? Yeah. So if the requirement is only for client identification and analytics, right? That means for rate limiting, throttling, this should be fine. And if we are dealing with, if we are not dealing with sensitive or mission critical information, like Google Maps, news, weather, those stuff, should be fine. And also if the requirement is to provide only read-only access to some non-confidential data, then again, it should be fine. But remember, there are better protocols that can do the same. So if you decide to use it, what precautions should be taken? TLS, it comes always, right? So for everything I'm going to discuss, TLS is there, right? So protect the keys at rest. You can, again, encrypt, store in a secret manager. Don't store in XML in plain text, please, right? And don't send the API key as a query param, because it will get logged in all the proxies. Send it in a header, right? And don't reuse the same API key in multiple applications. It's obvious, right? You are increasing the threat space. Now we are coming to the current scenario, current era, we can call it, right? So Oauth 2.0, how many are dealing with Oauth 2.0? Heard or? Okay, there are a lot, right? So you might already know how this works, but let me quickly refresh. So it's a delegation protocol, right? That means, what is delegation? Take an example. You go to YouTube. You want to share a video in your Facebook timeline. Now, you are lazy to do that by yourself. You can do it, right? Copy and go and paste. But you are lazy. So you click share. You are giving permission to YouTube to go and post something to my timeline in Facebook. Totally two different external services. Right? That is delegate. You are delegating YouTube to do that. Right? That's delegation. Now, how this used to happen before Oauth came was, for example, Twitter, it used to ask for your email username and password. Right? So it can go to email and find the contact list and send an invitation or something. So you are giving your credentials, which are of Gmail maybe, to Twitter, so it can do this. So Twitter will say, OK, I'm not going to use this for anything else than sending this invitation. But is it a guarantee? Do you know that's the case? So this is how it used to be. That's why people came up with a delegation protocol, where you get the delegation done, but without giving your credentials to that external service, right? So Oauth 2.0 is also a framework to build other protocols. Heard of OpenID Connect? So Oauth 2.0 goes, OpenID Connect goes with Oauth 2.0, right? UMA, how many have heard of UMA? User Managed Access. Okay, that's one. So this is the current state. I mean, this is the future sort of a thing, right? So what we discussed with the Oauth was delegating a client app to do something on behalf of you. User managed access is delegating another person to do something on behalf of you. So I'm not getting into those details. So this is not widely used yet. So I'm skipping that. Also, using Oauth, you can have your own authorization flows configured, right? It's a framework. You can build your own custom flows. So in that YouTube scenario, what happened was you went and clicked share, and did YouTube ask for your username and password? Did YouTube ask? No, who asked? Facebook asked, right? So I, as an end user, go to the Facebook. That's where my credentials are. So I had no problem with giving that, right? And then Facebook asks, are you okay to allow YouTube to do this? Yes, I give the consent. Then what Facebook sends is a token. That's all. To YouTube to do this thing on behalf of me, right? So there can be two types of tokens. One is an opaque token. That means it's just a unique string. There's nothing inside that, right? Then the other one is a self-contained token, which is usually a JSON web token or a JWT. We'll get into that later. So these tokens has an expiry. So unlike the API keys, these are usually very short, usually 1 hour, right? So you can configure this depending on the sensitivity of your application. Oops, sorry. Right? If it's really sensitive, you can restrict it to 5 minutes or something, likewise. Also, there's a possibility to refresh if you wish to. Otherwise, you have to keep on getting user credentials, right? So you can refresh. Also, in Oauth Flow, there are 4 parties. Client, that's a YouTube. Resource owner, that's me. Authorization server, what do you think? Facebook, right? And resource server, in this case, again, Facebook. In this case, both are same, right? It's not the case always. Also, these are scoped. The YouTube can't do anything more than what I consented to, right? Unlike API keys. So these are scoped to the resource level, to the HTTP method level. You can do scoping. Okay. So there's something, a concept called grant. Basically, that is a use case or some flow that where the Oauth can be used for, right? So we have authentication flows from mobile apps, single-page applications, lot of other scenarios, right? So the nice thing about Oauth is it's flexible. So you have this thing called grant where it suits for these different mechanisms, different authentication flows. So authorization code grant, we'll look into a bit more details later. I just chose this so I can show you the Oauth flow here in a more clearer manner. So you can see there's an client and the resource owner and the server, author server and the resource server. So this is what we discussed about YouTube and Facebook, right? So first you get, the client redirects you to the Facebook authorization server. User give the authentication and consent. Then it sends something called an authorization code. This is a nonce value, temporary nonce value. This happens through browser. And then as a backchannel call, application, the client will do another call to the authorization server to get the actual access token. That is what the client sends to the API, not this temporary authorization code. I am not going into details why there are 2, right? So Oauth itself, we can talk for about 1 or 2 hours, so I'm not going into that detail. So these are some common grant types for different flows, right? Authorization code grant. So what it's suitable for? So if you are building a web app, a single page app, or a mobile app, this is the grant type you should go for, right? For web apps, for single page apps and mobile apps, those are treated as public clients. That means you can't guarantee the secureness of them, right? Those run in browsers and in mobile phones. So anyone can dig into that and find out the client secret, we call it. So to authenticate, so to the authorization server to know about this client, it has something called a client ID and a client secret, right? So client secret, to be a secret, right, it shouldn't be there in a public app like SPA or a mobile app. So in that case, you must use authorization code grant without client secret. Now, if you are going with the mobile app, there's something called proof key for code exchange. That must be also used. Otherwise, the code that is getting returned from here might go to some different mobile app, right? Because mobile apps can register for callback URLs, right? And then that app can get the access token. So proof key means it proves that this particular client did the request, right? Okay. So then the implicit grant is deprecated. Don't even think about it, right? So if you are using that, think about the authorization code grant without client secret, right? Then client credentials grant is basically there's no end user. It's the client app, authorization server, and the resource server. So client app is the sort of the user itself, right? So if you are dealing with data that are not specific for end user, for example, weather or stock, right, you can use client credentials, the client ID and secret given for the client, right? Password grant, again, not recommended to use, right? Again, it's like using basic code. So you are giving username credentials at one app, and it's sending this request to another, to the other server. So again, the credentials are getting exposed. So don't use password grant. So there are some situations. One is if the app and the authorization server are owned by the one entity, for example, Facebook app and Facebook authorization server, one entity, right? You are giving the credentials to that one entity, right? So that should be fine. And also there are cases where, for example, there are clients without browsers, like smart TVs. In that case, this is what used previously, but now Oauth has come up with something called Oauth Device Flow for smartphones and similar devices where browsers are not supported. Right. So SAML bearer grant, JWT grant. So SAML SSO is an authentication mechanism, right? So if you already have SAML in your app, you can use this grant to get an access token to call the API. And if you have some mechanism, some authentication mechanism using JWT, you can use the JWT grant to get an access token. Okay. Right. So are there any problems of Oauth 2, or is it perfect? It solves everything? No. It has a major gap. Right? Again, remember, it's a delegation protocol. It's not an authentication protocol. Did you know that before? Yeah. Right. Why it's not an authentication protocol? In this picture, okay, this access token, does it contain the username or user claims or anything related to the authentication, how the user got authenticated? No. Right? The client is not supposed to check inside the access token. It's who needs to check that is the resource server, right? So this is only a delegation protocol, not an authentication protocol, right? So the authentication part is was missing. So you had to use something like SAML to SSO for authentication, and then use Oauth 2.0 to get the token, right? So that was a major gap in Oauth 2.0. So when to use it? If you need delegated access like we discussed, use Oauth 2.0. Are there security precautions to be taken? Yeah, so you have to make sure you set the correct token expiry according to your app, right? Always API security means it always depends on the audience of the device, right? You can't have one rule that applies to everything, right? Then if you do that, it will fail the whole the system. Also use PKCE and define granularity of your API carefully, and assign scopes for those granularities, those fine-grained level access. Protect the client credentials at client side, use encryption, and again, use TLS. That's the happy face, right? So what was missing in Oauth? Authentication. What does OpenID Connect provides? Authentication, and what Oauth was providing. Right. OpenID Connect is built on top of Oauth 2.0 to provide that authentication layer. Right. So if you are thinking of building an app, and if you want authentication and to access API tokens, this is what you must use. Right. No need to go and check anything else. Right. So this solves the problem of apps having to use a separate protocol for authentication. This introduces something, a new scope called OpenID, right? This is just a label. It doesn't mean any permission level, right? So when you send, so I'll get into the flow later. Also, it introduces a new token called ID token. Remember, we told the access token didn't have any user information? So ID token was introduced to give those information, right? ID token is meant for the client app to use. Then it introduced a new endpoint named user info. If you want something additional than what ID token provides, you can call this endpoint and get those data. So all of these are for the client app for authentication purposes. Clear? Okay. So it's very lightweight. So SAML to SSO was the ruler sort of a thing in authentication, but now it's becoming OpenID Connect. Right? So quickly, the differences of the previous flow and this flow. Now, when returning the access token, you can see another token getting returned, ID token, right? And then you can send a new request called user info. Before that, in the initial request, you had to send this scope equals OpenID. That's how Auth server knows now this is switching to OpenID Connect flow, and I must send the ID token, right? Okay. So the problems, it's complex than basic code and API keys. Of course, you have to do a lot of stuff, but there are libraries. So this investment is totally worthwhile, right? So go for it. When to use it? Any use case where delegated access plus authentication is needed. Security precautions, everything applicable for Auth 2.0 applies here. Don't use ID tokens as access tokens. You might be tempted to do that. Send the ID token with the API request. Never use that. ID token is meant for the client. Access token is meant for the resource server, right? Yeah, so ID tokens and self-contained access tokens, that means self-contained access tokens are also, as I mentioned, it's a JWT. So those must be properly validated before using. So we'll check later what are those validation points. Yeah, later means in this slide, right? So JWT-based authentication. Is JWT an authentication protocol? No. It's simply a data container. We can say an integrity-protected a data container, right? Remember those key 6 attributes, integrity? How we protect the integrity here? By using a signature. I am not going into details how the signature is constructed, right? You might already know about that. So if something is changed, then the signature fails, right? So it can be signed using a shared secret or a public-private key pair. Here the example I had taken from jod.io. Here it uses a shared secret based on HMAC SHA, right? So basically, this is a normal JSON payload. Here you can see the JSON payload. In addition to that, there are 2 additional parts. One a header, which informs what the algorithm that was used for signing, and then the footer part, that is the signature, right? So these get transmitted as headers in this format, base64 encoded. All 3 parts are separated by a dot, right? All 3 parts are base64 encoded separately. Okay, so JWTs can be used as self-contained access tokens and ID tokens. Also, these can be encrypted. They are standard called JWE, JSON Web Encryption, right? So if your app is a sensitive app, these must be encrypted, right? Yeah. Okay. So what are the problems of it? Now, JWT-based authentication is sort of a favorite authentication mechanisms for microservices, right? So simply, one microservice can generate its own JWT and send it across to another microservice. There's no need to go and check user stores and etc. You simply validate the signature and you are done with. Now, if the microservice can't generate, it can be generated from some other external parties. So usually this is done in a sidecar, right? This communication happens in a sidecar. So the key problem is how you distribute and revoke or renew these shared secrets and certificates with 0 downtime, right? Think about a system where thousands of microservices are there, right? And you scale up every day, scale down. How do you distribute this? That's the key problem here, right? So there's already a standard for that called Secure Production Identity Framework for Everyone, SPIFFE. So this is used in service measures. I think Istio uses that, and maybe on OI linked those. So that's the key problem. But once that initial bootstrap is done, then it's quite easy, right, to use this and to transmit data. So when to use? If integrity-protected data exchange is needed, this can be used, especially in service-to-service authentication in microservice architectures. What security precautions you should use? JWTs must be validated properly, right? Do you know which ones to validate, which attributes to validate? Right? Check the spec, but I have mentioned here as well. So you have to check, first thing is to validate signature, right? Don't go and validate others before validating signature, there's no point. If signature is invalid. You have to check who issued it. So there's an attribute claim called ISS. So these are standards. These are not custom ones that you put, right? Then there's something called expiry EXP. There's the expiry of date of the JWT. Then you have an issue date time. So if the issue date time is in the past, then the service can reject that, saying, I want a fresh JWT. What the heck is this? And then there's something called not before time. That means a JWT is issued for a future time. You must not be used it before that, right? There can be some other processes that needs to be in place by that time. So until that time, you must not use that JWT. And the audience. This is also very important, right? So if you don't validate the audience, I can replay this token to different microservices, different services, and whatnot, right? So audience is, I am checking whether this JWT is issued for me, or was this something issued for someone else and someone trying to replay that to me and get authentication. So this is important. So if you must encrypt it, if you are not using TLS, so I must remove this line, right? You must use TLS. There's no point, right? And of course, keys must be protected again. Right, so Tls Mutual Load, we are all familiar with this. So in addition to the server authenticating to the client, sending a cert to the client also authenticates to the server. This is very traditional, right? It's been there for a long time. And it's very successful at what it does. Simply, it's proving that I am the client that calling you. This is not someone else trying to impersonate me or something like that, right? So the problems of it is it doesn't indicate the end user. It indicates the client application. That's fine, right? That's what it's meant for, right? So the initial effort, again, like JWT, initial effort to setting up the infrastructure with proper certs and then handling the certs, renewals and rotations, this is a bit of a trouble. But once you have those systems in place, automated systems in place like Spiffy, then this just smoothly goes on, right? So this is especially used in service-to-service authentication. This is very common in service meshes, I believe, right? As sidecar in Istio, I believe it gets automatically plugged in as sidecar. The service developer doesn't have to worry at all. So what security precautions? Same stuff, rotate the keys periodically and take measures to protect the keys. Okay. So that is the mostly authentication. Oauth 2.0 is a bit of a weird case. It's not authentication, not authorization. It's a mix-up. Now we are coming to fine-grained authorization, right? What is fine-grained authorization? So we all know role-based access control, right? So you define a role and you assign users to that, and then you assign set of permissions to the role, right? So whoever having this role can do this stuff. But does it solve the problem like, for example, I take an online wine store, right? You can't access it if you are not 21 no more, right? Can a role-based access control solve that problem? That's a very simple example. That's where this fine-grained authorization, or it's called as attribute-based access control also comes into the picture. So SACML is sort of the de facto standard. It's a standard defined out there, but it uses XML to define what we call as policies. So this decouples the authorization logic from the application code. Now, earlier, you write your own rules, and then you started to use rule engines to get these things done, right? But still, you are coupled with that rule engine, right? You are calling its API, its interface. You are coupled to that. You can't switch to a different rule engine and get it done smoothly, right? So those problems are there. Now, SACML, it decouples these problems, right? The policies are maintained in files. Those are XML files. It was the good idea at that time, but not now, right? And then this is a standard, right? So you can choose different SACML vendors right? So there's Axiomatic, there's WSO2, there are other vendors that provide this. So you can switch between the vendors depending on the features they provide. There's no coupling, right? Okay. So these policies are based on a subject, resource, action, and environment. So basically, what I can do on some data or some resource, right? Subject is me, resource is the endpoint you're trying to call or the resource, action is read, write, or post, get, and environment is some contextual information regarding that communication. So it consists of 4 key components. One is called a policy administration point. This is where you go and create policies, right? Then you have policy decision point. This is where the decision is made using those policies. Then there's a policy information point. Now, if something is missing, some information is missing, the policy information point can go and grab that information. For example, the subject can come as Dulanja, right? But the authorization need my roles. Now, PIP, or policy information point, can go and get those roles of Dulanja. Right? Those are not coming in the request, right? Then policy enforcement point is basically your client app that is calling the API, right? That's where the policy is enforced. It's calling the PDP, sorry, not the client app. It's the API that is calling the policy decision point. Okay, this says my time's up. Okay, so this is the last section. Have you heard of OPA? Open Policy Agent, right? So this is especially, it's an open source general purpose policy engine. So if we take a look at it, it uses JSON. And also here for the policies, it uses a new language called Rego, right? You can write in Rego, and also you can provide set of data to that policy to evaluate for, right? So this is very flexible than SACML, and this is used with the current microservice architectures, right? So this can plug as a library. This can do calls to a central, the API can do calls to a central OPA server, or this can be plugged as a sidecar with your service to do this authorization. So you can write using the Rego language policies that works for any stack in any domain, like for microservices, web apps, Kubernetes, CI/CD pipelines, API gateways, and etc. Right? This is very, very flexible. Yeah, so input and output is JSON, and it's quite lightweight. Right. So this is how usually the policies are synchronized. So there the services are there, then there can be sidecars, and this sidecar, this OPA engine can periodically poll whether there are changes to the policies. So this is how it syncs across your microservice architecture. Right? So this OPA engine resides with your service, your microservice. So it is very efficient, fast. It doesn't need to do a network call to get the authorization done. Right? Yeah. Then it can also send out its statuses. What's the last state of the policy? And also it can send out login and monitoring information. What were the decisions that I took? It can send to a central place. So this is quite interesting. If you have a chance, take a look at OPA. OK, done. So I try to cover, touch a lot of areas. So you have an idea. You can go and check those, or we can have a chat. So another key thing when it comes to API security, sorry, just 1 minute. These are authentication and authorization mechanisms, right? So there are other aspects of API security, right? How you design your resources, right? What level of granularity you are giving to them, right? How much data you are exposing. For example, if you have a Java class and it's mapped to a JSON output, right? You might be giving out unnecessary information. You expect the client to filter those out, right? So there are aspects like these. So I recommend there's something called Oasp Api Top 10, which is in release candidate right now. I believe it will go GA soon. You know Oasp Top 10, right? Web Top 10 and mobile Top 10. So that is the governing body sort of a thing, right? So they are coming up with this. So go and take a look. It's quite easy to understand. It's quite interesting because the simplest things that we are not doing, the things we know, right? So that's it from me. Yeah, I hope. Yeah, now it's halfway done in the lunchtime. Sorry about that. OK, thank you very much.